You know how sometimes in math class you start off with what do you think, and then it's usually an example to show you, yeah, what your gut was wrong. Well, this is a case where what your gut feeling is should be right. Okay? If you know the derivative of x squared is 2x, okay? You know the derivative of 3x is 3, and the derivative of a constant is 0. It just so happens that the derivative of this whole thing is exactly that. Take the derivative of each individual thing, and you have the derivative of the whole thing. Again, how are you doing with memorizing these, like the definition of the derivative? Limit as h, hopefully better than me, f of x plus h minus f of x over h. This one wouldn't be a hard one to do the definition of the derivative. Would you like to do a definition of the derivative just for practice and review? Okay? So this is how quick we get it with our new rules. And with the definition of the derivative, first of all, you'd plug in x plus h. You can just watch. You don't have to write this down. X plus h in for each x. So it'd be x plus h squared plus 3x plus h minus 7 and just move a little bit over here. Is that okay? Minus f of x, which is right here, x squared plus 3x minus 7. Notice I'm subtracting the whole function, so I put it in brackets to begin with because I'm going to have to subtract each thing, all over h. Now we'd have to expand and combine like terms. It's still going to all be over h. This will be x squared plus 2xh plus h squared plus 3x plus 3h minus 7 minus x squared minus 3x plus 7 once I distribute that negative. So I expanded the x plus h squared. I distributed the 3. And nice things happen. Those cancel out. Those cancel out. Those cancel out. And on the top, we're left with 2xh plus h squared plus 3h, which if you factor an h out because it's in common, 2x plus h plus 3. And now our h's cancel out. And we can plug in 0 for h. And we get 2x plus 3. So we start to really like the idea that we get these new rules for derivatives, because before that, we would have to use the definition all the time. And as far as saving time and length of the question, I think this method here, where you just write down the answers, a little quicker. All right. This is a sum and difference rule, that if you've got functions that you're adding or subtracting, and you want to find the derivative, you can just find the derivative of each thing separately, as long as you're adding and subtracting different functions. Here's a great example. Have you got a guess? Have you got the answer down? Do you want to see if you're right? Did you get f prime of x? Bring the 2 out in front to make 16. Subtract 1 from the exponent to get x plus 3. Part B, fractions. Again, I'll give you a little head start. Different notation here. This is a new notation. it means the same thing as f of x equals. The way that this notation would be read is you have a function that takes every x and changes it to this, which is basically what function notation is. You plug in an x value, what do you get? Nine times 2/3 would be 6. Subtract 1 from the exponent, you would get negative 1/3. 10 times 1/5 would be 2. Subtract 1 from the exponent, and you get negative 4/5.